recording. Okay, let's start with the fold. So
Let me join this trash. Where's the link? Oh, here.
yeah. So let's do. The first question is: are we gonna have just fold or fold like direction based?
Oh, we can do fold back, fold.
Wait, what would be the non-direction based?
Just
Oh,
fold.
just fold left.
Yeah, just fold.
Yeah, that's still direction, right? Like you
No, yes,
implement.
but like
Not in the name.
without. Yeah,
Yeah.
I got you.
Yeah, we can have fold back and fold forward, I guess.
Oh
Fold
god,
fold. Yeah,
that
it's just
sounds
that
terrible, man.
F sharp just names as fold and fold back. That's why.
Okay, so we can do we can do both, I guess. So let's say that it is a value.
Dude, I just wanna
Value.
log in. What the heck? Wait,
Pull
Mems.
down what?
I'm in this live share bullshit, man. Join. Okay, I think it worked.
Okay, so let's start. So we're gonna add 2 here. So one of them will be fold, and that will pick this guy.
Yuppie, it works.
And then we're also gonna have fold back. Like this. Okay, so let's think about the type now, I guess. What is the type of a fold?
It was on GHCI.
Just copy the GHCI.
Well, okay.
Oh, you already added here.
Okay, so this is the type.
The other. That's the fold back, right?
This is the fold back.
So let's see, this trash will pick a function.
Lemus, take a look on the type signature of the left one, because I think they changed the order of the
They change.
The arguments.
They change the order of the arguments.
So what will be the argument list? You pick the function, then a special, the initial, and then the elements.
The elements, and then you fold them.
Okay.
Reason to change the order of the arguments? Can you guys think of a reason?
I can only think that there must be a partial application benefit, but I don't know.
Partial application benefit.
Oops.
So we need just change this. Oh man, it's gonna be 3 native functions, right? Because we gotta have 3 things.
Wait, I'm confused. Why?
Copied here, down here, the filter, right? And we're gonna have to do 3 native functions nested, right? Because we now have 3 arguments.
Oh yeah. Yeah.
So let's change this.
No, let's do the type first.
Oh, the type is the same, isn't it? Oh no.
I don't think the type is the same.
No, it is. It's gonna be a value. Value to result type. And then here we pick other things.
No, yeah, but for like
He's saying the type of the native function.
Yeah.
Okay.
But that's a bit odd, right? The left starts with the accumulator and then the element, but the R is otherwise. Like, I'm a bit puzzled with that. Maybe they have a reason, but
I can think about a why right now.
Yeah.
Okay, but I think that the beginning is the same. It's true for alls.
Yeah.
So for all A and for all B, and now it starts the changes because this arrow right here is this one.
Let me see.
So now we need to do a T arrow that picks. Well, I think we should do this is the fold, so this is the first one. So picks an A and returns another T arrow, right?
What is the T there? The TA.
TA. Oh, it is because it has a constraint, right? The T
traversable.
needs to be foldable.
Oh, okay.
Yeah, so I think it is like this, right? And then you put t variable b here, right? So it's a function. I don't know if I'm doing it right, so
So
feel
let's
free to
see.
fix me.
Oh man, this is so
Correct me.
nested. Wait, it's an arrow
Yeah,
that picks another arrow.
yeah. This another arrow. It should be this thing.
So this thing. So which picks an A to a
To a
what?
function,
Wait.
it picks an a and
Oh,
returns a
because our
function.
arrows. Okay, I get it. Because our arrows are nested, right?
Yeah.
And then pick an A and B and a results in a B. Then you
Yes.
have another arrow that is just the initial thing. That
Yeah.
is if
No,
the
no.
same
This is
type
wrong.
as B.
No, but that's the thing. I from now on, this is just copy pasted. So this is wrong. But I want just to confirm if this is correct. This other part that I'm highlighting here.
Yeah, yes, looks like. And then this doesn't matter if it's A or B. That's up to us.
No, no, no. This matters because this needs to be a thing that grabs a t variable b, right? This is the initial
No,
value.
what I'm saying is like the label of the variable doesn't
Oh,
matter.
doesn't
It
matter. Doesn't
matters.
matter. Then we need to have a list now of type A, which is this. Actually, this needs to be another arrow, right? So t
Oh
arrow.
man,
Yeah, the
dude,
nesting.
can you format this code?
Yes, I guess so.
Yeah, but I think we need to finish writing here because it's gonna fail.
Okay, so we pick a B, then we pick an A, then we pick, this should be just a B, right? So t variable B. And now we need to figure out how many parameters we are lacking. Oops. Okay. Okay, I think that must be it. So let's go again. For all A and for all B, the first parameter is a function that picks an A, which is this, and returns another function that picks a B and returns a B. Okay. Then the the second argument of this guy, right? The second argument of this is a b, a t variable b, right? That is it is a function that picks a b and returns this thing. This thing is another function that picks a list of variable type a and returns type b. Yeah, I think that must be it. If we don't want to flip the order of this thing, the foldback has the same type, right?
Yeah. I don't see the reason why flipping here.
Yeah,
So
I also don't see the reason. So I'm just gonna copy paste it here. Okay, now we need to add those. Okay, so the type of fold, the type of fold back. I should take a look on the chat because maybe Nathan is writing stuff. Uh, fold type. Actually, we just need the fold type. We don't need both then. If you're not gonna change it. If we ever decide to change, we can just copy paste and change the order there.
if we ever change later.
Okay, now the hard part, the function.
Oh man, this function.
It's gonna be
So,
so
oh
nested,
man,
holy crap.
it's gonna be horrible, man.
Okay, so it is a thing that grabs a value. It is a thing that grabs a value. This value must be a closure because it's a function.
Yeah.
Right. Then the second thing is not a list.
Yes.
The second thing is not a
We can keep
list.
this and the last one. Let's just do so we don't change too much the structure. Never mind. Let's just nuke this.
No, don't nuke it. No, 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 no,
No,
don't
we
nuke
have it
it.
up
We
here,
will
man. We have it up.
reuse it.
We have it up here, man. We just remove it. It will be harder to think with this shit here.
Okay, so now we're gonna do accumulator. What should this be? This should be which type, which value are we expecting to the literal, I guess, right?
That will depend, right? That's the problem. It's a t variable actually.
It's a t variable.
Yeah, it could be, I don't know, functions and then you're folding composing them. I don't know, man. It's somehow. Oh, but like functions in this case would be closures, so they are still values.
Yeah, so the question is, what
Yeah,
is
in this
the...
case it's all literals. Yes, it's not exactly literals, right? It's all values here.
Yeah, the only one you care about is to see if the one is a function. Like the others, you don't need to match on.
Oh, really? Okay, so if
They
we
are
don't...
generic, right?
Yeah, okay, so we receive an accumulator, right? We receive an accumulator. What should we do now then? I guess return with the next one. V native function.
Oh.
And then we copy paste this thing.
Is this right?
HLint is complaining a hack here for me, so I don't know. But that's not a problem. Let's now check. So you are expecting to receive a list after. So you receive a function, which is the folding function. Then you receive the accumulator. It can be anything, so you need to match. Then you receive a list. It needs to be a list, so you need to match that.
Oh yeah.
And then the final thing is this line here. So
Delete.
okay, so let's see. This will not end with a list. It needs to end with a...
Yeah, value. But which one? That's the problem.
That's the last return. Oh
Yeah.
yeah.
Yeah, how are we gonna do that then?
Well, we need to match the result, right? Depending on the result of this expression, we result it. We wrap.
Okay. But then let's continue here. So pick the list of things. You evaluate them, and I'm assuming that these...
Let's put it like this. Oh man, why is HLint like so? Disable this shit, man. I wanna nuke this garbage. I'll leave it
It's
like this.
fine.
I
Dude,
can't
I think
read,
we have a
man.
problem, Amos. Do you know where we are matching with closure?
Yeah,
It could also be a native function.
that's true.
Yeah. Yeah. It
But
could
we
be
can
like
worry
with
about that
a.
later.
That got into the spirit.
Yeah, but I'm still having a problem because we need to send to whatever is happening inside. We need to send this guy in, right? This guy needs to participate. Am I going crazy? Because each value A is each element of the list, right? And then we are picking the value A and passing it to the evaluation function that has a body and stuff. But I think the result of this will be another function, right? This. Hello, people?
I'm listening.
Because
Um,
this function needs to receive two things, right? An
Yeah.
element and an accumulator, and returns another thing. So it's like an A to an A to an A. And as far as I can tell, we are passing only one A to it. We need to pass another one.
like, can you put the signature closer to the thing where? Okay, function initial value. Okay, so this value that you are calling is a function, right?
Yeah.
Yeah.
And then we
But it
have the
is this, right? It is this.
yeah function.
No, yeah, but it is a function that different than the other cases. It has two
Mm-hmm.
things before outputting the final thing.
Okay, and also we have yeah. There is not really the accumulator, right? It's the initial value,
Yeah, it's the neat value.
and then we have the list.
Yeah, so as far as I can tell,
And
this A
now
here is this A
wait,
here. So the result of this will be a closure.
wait, B, a list of A. For every A, yeah, we receive another one, and we should pass.
This.
Yeah, we don't, yeah, we cannot use the for there. I think we need the fold, right? Because we are not having a way to pass the
Yeah, there.
ACC and get
There.
back on the for.
Yeah. But
Um,
this would have to be slightly.
okay,
Because
but
let me see. We need to.
I think okay. So let's make the folding function that we will use the fold for.
Yeah, so it's just a fold, yes. Okay, I was thinking way more complicated, but yeah, it's just a fold. We evaluate the thing,
Yeah,
then.
element.
I guess it is
But
still
here's the
complicated
thing:
because
does
of
the
the either.
field,
Yeah,
does
no.
the fold?
Yeah, exactly.
But here's the thing: what if it fails?
No, but we're gonna match it.
Oh, okay.
So it's gonna be this and this.
Oh man,
Uh,
that sucks because you still have to. Let me see. You still have to run the function on the values, right? Not on the.
wait a second. No, man, we can still use the for. We don't need the fold. We can use the for, and then this is the first guy. We need to make a function here that will call eval
The
and pattern
body.
match.
No, no.
So
What I want to know.
the next argument is the accumulator lemons, and
Yeah,
you have to pass through each iteration.
yeah, I know. Just
Does the
let me just
body.
try. So this will be a function that receives an element because I want to put fun in
In
here.
this case, the body just picks like whatever is wrapped, right? It doesn't care. Like it doesn't pick a literal. I mean.
So then you do doesn't pick a literal. What do you mean?
Yeah, it does. Sorry, it does pick a literal, but like not the. Here's what I mean. Like, uh, v literal bull. I don't know. T bull. I think we're just doing like.
We can't mess with literals in specific.
Yeah, so like we can't do these right for that thing. Like it picks that and integer, I guess.
Wait, I'm not getting it, Nagita. What is
Like,
that?
does that body function picks these or these? That's my question.
Oh, okay, I see, I see.
I think it picks these, right? Because on the floor we weren't doing anything. We're just evaluating and then.
Yeah, the val takes an expression, right? So,
So if this is a left, we're gonna have an error here. Then we're gonna fail with that error. Uh, yeah. And if we have a right, then we need to pass the accumulator to it because this will be a function. This thing, like this should be like I don't know. I need to make better names, but this should be a function. Partial applied, so this should be this function here. Then what we need to do is to discover if it is actually a closure, right? So do case function of, because if it's anything else aside from a closure, then it's wrong. Closure, uh, label, body, env.
I guess we could do some, like, monads to match specific stuff. Like a monad in with the right case, it's a closure, right? Then we can use do notation, I guess, for.
Oh, you mean like, oh, if you're not a closure, you fail immediately, the denotation?
Yeah.
That would be fancy. So eval, map, insert, label this with the element accumulator, with the new environment, and we also need the new body. Yeah, and everything else is in error. Everything else is just uh, expected a closure um, in the fold. Found something else. And then this. Look at H lead going
Oh,
crazy.
Yo,
Lemus,
I
you
hate
use
this
the
lead.
bad closure again.
The bad closure.
Yeah.
Oh, I used the bad closure again. No, wait, what?
Massive, man.
Oh, now your message. The bad closure. Yeah, so let me try to explain what's happening here. So, we have our list of elements, right? Which is this list prime stuff. So for each one of them, we're going to apply the function fun. Oh,
But the ACC is always the same, right?
yeah, we need to pass that on, right?
Yeah, so fold, I guess.
Yeah, but
Oh
it
man,
is
this
a
sucks.
fold that needs to handle the...
Folks, why don't we do a 4 and then we just do generic computations with assignment on a 4? Like,
What?
why don't we drop the fold and just do a 4? And then, you know,
That's
I think
fair.
it's harder. I think it's actually harder.
I don't think so. It's a generic construct versus this scrap with a closure, man.
Then recursion is easier to implement.
What?
Yeah, because you will need mutability to the far.
No, you don't need mutability, man. Like, we already have the map. That's what I'm saying. We can just mimic the same thing on a array of things. Not array, like on a list.
Anyway, let's keep this code
But
for
we don't
now.
have oh man, we don't have iterators like picker and such.
Oh, we can make them.
I'm not sure how to do them right now, to be honest.
Yeah, I also don't know. But anyway, let's keep this code around here because I will tackle this later because we need a fold that I don't know. I don't know a fold that does what we were talking about.
It's just a normal fold. It's just annoying that you have to match stuff inside to see if it's like left or right and shit.
Oh yeah, but that seems like something that is already made. I just need to research a little bit. Anyway, so what else can we do today aside from making? Oh, we need to finish judging if the omega is done, right?
Yep.
Yeah, we need to do that. Okay, so let's go to types.hs. We need to check if type substitution makes sense. We need to check if the equality makes sense and stuff like that. Okay. Okay, so let's start with the type substitution.
Wait, why don't we start with kinding? I guess it's the easiest of all.
Oh, there's also the kind checking, yeah, down here.
Let me just get the book, man.
Okay. Oh, we also have reduction. In the meantime, I'm gonna show Mageta what I did yesterday. Mageta, can you see my screen?
Yeah. Oh wait, I am looking at the code. Let's see. Discord.
Yeah.
Yes, I can.
Okay, so let's suppose that you want to use the thing, right? The compiler. You're gonna do like that. And then it will say to you, look.
Oh, you added actually like file checking.
And then let's suppose that you want to go to the repo, right?
Why the knife, man, and the spoon?
Because I didn't find a
together?
spatula, man. I had to compensate somehow. Okay, but let's suppose that you do want to provide a file, but you don't want to do everything. You want just type checking. Maybe you want just the result of the parser.
So the type checking picks the last expression, right? You mean?
Yeah, yeah. It is the type of the entire expression that we have on that file.
I see. You just did the last one for Nathan, right? He's just gonna be using that.
No, this is so useful. We need this.
No, he will just use that.
No.
You allowed him to only use that.
No, I will not use the binary. I will use the library.
Oh yeah, I forgot to.
There's also this one. Oh, by the
it.
way, these flags, they are doing like, they're not doing the entire pipeline and just printing to us. They are doing like, oh, if you pass me this flag, I will just do this, right? So it's individual, and I did for evaluation also, but it's not type checked. You parse and then you evaluate, and you can mix match. You can mix match them like this in whatever order you want. And if you provide nothing, it will do the entire pipeline, which is parsing, type checking, and evaluating. You can check it out, all of them here.
We we're done with the typing, right?
Yeah.
Do you remember if you were talking about kinding when we are typing?
No, we didn't.
Like at all?
No. We checked when we should kind check while type checking. We just don't
Yeah.
know if the kind checking is okay.
Oh, okay.
Awesome.
Uh, yeah, the only thing I'm seeing here is that, oh man, I think I'm a bit confused here. Like it's on the page 451,
Let
but
me open again that thing.
yeah,
I mean, Pierce's book.
yeah.
Where is the code? Where is the link?
Um,
Come
I
on,
will
man.
send
Oh, you
you.
sent
That's
it. You
something you
sent.
should have in your bed, not in your like asking links for people. You should
Oh,
have
I
that
do.
book in your like on right side of your bed, so you promptly go and read it.
I'm not sure if we should show that though.
I mean, well, it doesn't mean it's illegal, right?
Yeah, we're not saying where we got it.
And I own the book, so
Yeah.
Excuses is
Which page are you
yeah,
talking
it
about?
is. It is. It's not an excuse. It's just
451.
I already bought the book. Then having the PDF representation doesn't really
No,
matter.
no, you having the book don't
No, but
excuses us.
we're doing a joint collaboration here. So
Look at this dude, man. Sounds like a lawyer.
no, man. Lawyers are 10 times worse, actually.
Okay, so are you guys seeing the gray part where it's like extending?
Yeah.
Yeah.
So yeah, you see that they talk about kinds and shit, and then they are using the same uh how can I say the same kind, right, for stuff. So in the first case of abstraction, I guess it's okay. Like we are not checking equality. We are just getting from the lambda, putting on the context and putting on the final for all. So that I
Wait.
guess is okay.
Wait. I'm confused. You're talking about this is type equivalence. It's saying. So this is
TABS.
key.
No, no, on
Key.
the right.
Oh,
On the
here.
right you have typing.
Oh, here.
Yeah. So see where we have TABS.
TABS. Yes.
Yeah, my worry was that we're forgetting something regarding kinding, right? But
No, but we checked this last time, and it's
I,
fine.
what about the TTF? Like, do you remember something
Yeah,
regarding
remember?
that?
We also checked that. This is the weird one
Yes.
in which they went out of space and they did one on top of the other.
Yeah, I remember.
Yeah, we already did this.
Okay. So can you check in the code if you are doing something like kind equal or something
We are
on
100%.
the TTF?
TT app is this one. Right here.
Oh, okay. Yeah. Yeah, I guess we are fine. Just my memory that is failing,
As always.
Oh, man, that's
really, really hard.
we don't even trust it at this point, man.
So, okay, let's go to kinding.
Okay.
To kind check.
Which page?
The previous one.
Kindy. Oh, here.
Yeah. Yeah, so go to the function and then I will read the rules.
Okay. Go.
So, let's see. The way we kind check a variable is just getting its kind from the context, I guess.
No, not always, right? Yeah, we have unit, integer, rationals, booleans, string.
No, a variable.
Oh, a variable. Sorry. Sorry. This. Yeah, just a lookup. Yeah.
Oh, okay, we have like the special ones, right? So all the literal ones like unit, integer, rational, bool, string, indeed, they are just star.
And
And the
the
list
list has the
in
special case that we talked about also last time.
Yeah, it's not really special, but yeah, if the X inside is star, then it is star also. Okay, yeah. Now let's go to the next one. The next one is arrow.
Arrow.
Yeah, not an arrow, a function, right?
Yeah, okay, a function.
Dude, I'm not, I'm quite confused with this thing here. Uh, this wait, dude.
Let's try to help you. Where is the function? Here?
Like this key, the K ABS.
K, ABS.
So that's the abstraction at the level of types, right? Like the
Yeah, T abstraction in our case.
oh, okay, the abstraction. Okay, okay. So let's go.
P abstraction. Okay, go on.
So the first thing we do is to get the kind that is on the annotation of our T ABS, right?
Yeah,
We put that in the context
yeah,
with its name, and then we kind check the body of the lambda.
yeah,
And then we just put in a kind arrow, I suppose,
yeah,
the kind of the annotation to the kind of the body.
yeah, yeah. So we are doing exactly that.
Okay, now we have the K application on
Yeah,
the book.
what's this?
So the first thing we do is to check if the function is a kind arrow.
Yeah,
So then we check the kind of T2 of the argument,
yeah,
and then we check if the left side of the arrow of the
yeah.
function
Mhm,
it's the same kind as the
mhm.
argument, right?
Yeah,
And if it is, then we return the right side of the arrow kind.
yeah. Otherwise,
Okay.
are just errors, right?
Yeah.
Okay, next.
So now we have the K arrow. So basically, we check if the left side it's kind star,
Yeah,
and and then we check if the right side is kind star,
yeah,
and if those two are, then the whole thing is kind star.
yeah. And otherwise, what happens?
Well, fail.
Okay, otherwise fail. Nice. Okay, so we have only
Now,
one missing here. Go.
yes, the for all, right?
Yeah,
So the first thing we do is to extend the environment,
yeah,
right? With the name and kind annotation of the for all.
yeah,
We use that to kind check the body of the for all,
yeah.
and that should be a star, kind star.
And if it's not, it's an error.
If it's not, it's an error. But if it is, then the whole for all is a star.
Okay, we are done. So kind checking
Yeah,
works.
nice, nice, nice.
Reduction.
So kind checking works.
Yeah.
Yes.
Yeah, like the kind equal is trivial, right? Like it's
Oh,
literally
kind
deriving
equality, you
equal,
mean?
right? Yeah.
Yeah, we are deriving equality.
Okay, makes sense.
uh,
Now we
re-
have type equality yet,
and
and like
reduction
all the other things that come with it, right? Like reduction,
and
substitution,
substitution.
and shit. Yeah. So what about doing with the type equality because it's the last one we have on the paper, I guess.
Okay, so the type equality is very easy. Everything aside from the for all is derived. So it's the like naive equality.
Uh, okay, so the string until to string like is like trivial. The T list, I would imagine that work as. Oh no!
Mm,
Oh, that part we have to derive also, Lemos. We have to make an exception.
okay. So what is different in the typed list for stuff like that?
Because if one of those is T list none, well, T list nothing, then it's already like the result is okay if the other is also a list.
Wait, can you repeat that?
Yeah. The list nothing matches any list. It's equal to any list.
Is equal. Oh, in the type level, you mean?
Yeah.
Okay. So
By the way, at this point, is it still worth it to do this for all the like types that we're going to add?
What do you mean?
Dude, I saw
Because
I saw an implementation. Let me just mention something that I think it's worth discussing. I saw an implementation of a dude on Hindley and he got from a dude doing Perl, and the code is pretty neat. But there was a yeah, but yeah, the code is pretty good. But there was something that kind of puzzled me, which was he defines constructors for types. So, for example, he makes like an arrow type. It's a constructor which is like a record that picks the name of the type and a list of the types that go into that. And you can already spot how he does everything else. Because, for example, an arrow would be, well, just the type arrow. So you know how the types will be represented. And then an empty list that picks two things. So he makes like a function, like in a constructor that picks two things: the target
wait,
and
I'm not
the
following Magita. Can you like
a,
go
a
No,
slower
right.
on the
no.
beginning?
Before that, I just want to remember what Nathan said. Nathan, you said that if you have a list with nothing and a list with a just, they are equal because nothing matches with
Yes.
everything.
Yes.
Why is that though? Can I ask that?
Yeah, it's because it would be like a generic list, right?
Oh, okay. So if you have, uh, wait, then comparisons with anything with nothing is true, right?
Yes.
Okay.
So if both are just, you check, right? If the two x's are equal. Otherwise, otherwise it's always true, I guess.
Like Visnata.
Wait, just a second, Magita.
Oh man, what the heck? Oh wait, silence. Wait.
Nothing.
Man, the Control Z shared here
Yeah, it
sucks.
is.
Okay.
And then that's interesting, right? What is inside are types. So does it work like neatly as we expect? Just put the equality between those, and it will get the equality of types, right? Oh. Let me just take a look on the rest real quick. Uh, the arrow, like just recurs, right? The variable, I suppose, is just checking if the strings are the same,
Yeah.
right? The for all, we have a special thing. Application. Okay, yeah, I think application is correct. The only detail is that you need to normalize it first
Oh yeah. No, but
before.
yeah. We need to pay attention to that.
And the abstraction. Uh, dude, the abstraction is also the case of the for all, like it's a special one.
Why is it special?
Because it has bindings, right? So it can be arbitrary binding and they can be alpha equivalent.
Oh, what matters is only the kind of the type. The text kind of doesn't matter.
Text doesn't matter.
Yeah, if you have a different name for the label, but you are what you said, alpha equivalent, who cares, right?
Uh, yeah, it depends on what sense you use. It doesn't matter. In the case of if we have to check, it does matter because yeah. But dude, that's the function. Let me take a look on the book, man, because I'm not sure if we need that.
In the meantime, what is this, Mageta? That you just did here?
So this is the way the dude was defining the types instead of defining into a union type.
Oh.
So I thought that was pretty weird, but it makes sense because it's, well, Perl, right? But I saw a dude that ported this his code to OCaml, and he kept this, and it was very useful, I should say, because he could define any type, and he didn't need to add things like this and check everywhere, you know.
Oh yeah,
And
that's in our case, yeah.
why is that like interesting? Because on Hindley Milner there's a step on unification that you basically like try to unify the like two arbitrary types that you pass to the thing. And then you gotta see if it's a variable or all the other combinations. So then I was thinking, dude, this could be kind of hard because we would have to unify with all these midget types here. You see, like and make a case for each one of them. There might be a generic case.
No, but that's the thing. That's another example of like having a T literal here, inside like
No,
which
yes, exactly. Like grouping, right? Yeah, I get you.
exactly. That's another example of use case of that. I don't know why we are not doing that, but we should. So
Lemos, indeed, we need the special case for the abstraction, man.
okay, can you explain me again why?
Yeah, it's the same case as the for all. So if you have for all A to A, that should be the same thing as for all B to B.
Yeah, so if they can be alpha equivalent because the text can be different, but
Yeah,
if the kind of the type are the same, then it is correct.
that happens with anything that makes a binding.
That makes sense. Okay.
Okay, so can you show me Magenta the thing?
Oh, I already
Oh
deleted
no.
it. No.
Control Z, but
Oh no, dude.
no,
No,
but
man.
it's fine. It's fine. Let me just copy paste this. Okay, go.
Oh no.
Go. Yeah,
Oh,
yeah.
here. So here's the thing. Like you see what he's doing? He's basically doing like constructors for the different types. So you have a generic tuple
Like,
of length
you mean
blah blah blah.
regarding creating a function to create the type?
Yeah, but here's the thing. He didn't have this like a union type describing all the types. You see, they just had a constructor that was like a variable, well, like a t variable and a t operator, which was basically everything else. So why do I think this
Wait,
is
Lemos,
a
okay. Go on, Magenta.
okay? So why do I think that's interesting? Because like on a step
Wait, I'm
there,
still not getting it. Like you have name, like that's a record,
yes,
right? The first
this would
one
be
I
actually something like t operator, blah blah blah, something like this. So which was a union type with like t variable, something like this, which was just a generic variable, you know, like just so
like
you
the
can
name.
identify. Actually, just so you can identify these in Hindemüller, you know, like a1, something like this, like you know.
Not quite, but you have.
This would be his t variables. So
Can you
in the
write that union case? You are saying just one that picks a name
that
and the
that's just
other is
two, man.
something else?
That's just two. Yes, it is a t variable that picks. I don't know. I think he picks an ID for the variable. I don't know, zero, whatever, and then it picks the inferred type for the variable. Inferred type, which is an option. So in this case, let's put like none. So if it's none, it's just a generic variable. But if
Okay.
it is restricted to something, then you swap it with, I don't know, something like this. So you could do this, but what he was doing was just doing like this with constructors for this garbage. So he had stuff like let, make, bool. Oh, actually like bool, something like this. And it was just a T operator.
The operator. You didn't explain the operator and the union thing
The
that
T
you said.
operator, this is a T union T operator. This is just the
Okay,
T
those
operator
two are in the sum
in the
type, right?
union, yes. And this thing is just. Are you highlighting, Linus?
Oh, I am.
Oh
Sorry
yeah,
for that.
because it just gets hard to see with the yellow. So and this thing is just to just represent any generic type. You see?
Okay, so you get the name and the
and the list of the flatted list of the types. So this part was a little hard, but
I am not quite getting that part.
dude, like
So you
this
get a
should be an
list of
arrow. Like
types.
what is an arrow? An arrow is from to something, right? This is an arrow.
Sure.
What he's doing is just flattening this to a list. That's it.
Ah,
Yeah,
He's just
that's yeah.
flattening. He's just picking the types. This is a list of types. That's it.
yeah.
And
That
then
sounds
he's doing the
unsafe as
tuple.
fuck, man.
Oh yeah.
No, but
That
it
doesn't
is,
sound like a good idea.
dude. That's Perl. Like you don't have union types, so he had to do
Oh,
this.
okay.
But what I think was useful is that he would not suffer because I was thinking if we're gonna do inference in the future, we're gonna suffer with all these cases on our list,
Oh, you mean this, right?
unifying them.
Yeah, you
And
can. You're
not
gonna
all,
unify all the literals. Like done.
no, I think the literals they are actually fine, but like combinations between all of those, we gotta think of like what is the combination of all of those. And if it were just a list, the combination is
I
trivial
get
because you
that.
just like swipe over the list, replacing the elements. If something appears in the list, then it's already like
I
a
get that.
unification.
I think I can be mistaken because I haven't taken a look into inference yet. But the unification that you need to do isn't just generic against some type, or
Yeah,
if you already have some constraints, so it's
yeah,
not
that's the only
generic
case. Yeah.
against a different one, then it's an error because you would need like two different constraints that you cannot like unify.
Yes, you
So
can
you
fall
don't
into
have
a
to deal
recursion.
with all the cases, man.
You
Like
do. You have to. Okay, what do you do on two different cases that are not T variables?
Like you just check if the thing is like a generic and you want to like refine to some specific type, or if it's some specific type, you just match with the new one with the new constraint. If they are equal, let's go. Otherwise, error. Like just
But
two cases,
but
right?
that's the point. To get to the unification, to get to the distinction, you only have one case you want to narrow,
When it's
which is
generic
one
and you have a new
when
constraint to a
one of
specific
them
one, right?
when one of them at least is generic. So you can be like A and B, and then A is a T variable, right? In this case here, think of his union type that he was making.
Oh, sorry, you're up there again.
Uh,
No,
Magueta,
I deleted. But
so you are doing like a match on two types and doing the unification would be
yeah,
some
you
kind of
pick. Yeah, you
so
unify on two. From what I saw, you unify on two, and then the unification is a match on that pair, and then you just pick just reach to the case where things
Magueta.
you just go
So
replacing until you restrict the thing to a variable into one
do
of them.
the wait, can you repeat that last part again?
You need to restrict the cases to the case where you get one of them to be a variable, so you can do the inference.
One of them should be a variable.
Yeah, like for example, you pick a t variable in a constraint of an arrow, and then okay, so now
The other matter, right?
yeah, it
The
does.
like the
Yes,
left
it
one, it's the
does.
current one type, and
Yes, it does.
the second one, it's like the new constraint that I'm matching against, right?
Let me see if I
So
find the code
isn't
here.
so isn't just the following case, Magenta?
Hmm.
If the first one is generic, then is the result is just the second one. Doesn't matter what the second one is.
If the first
And
one is generic,
yeah, so the current type generic. The second one can be whatever because the result will be
yes,
whatever.
yes.
But if the left one is something, you just need to check if the right one is something, like the same thing. Otherwise, you fail.
Actually, need to check if they are comparable, and that is the problem.
Oh, what do you mean by comparable?
Like for example, a tuple. You're trying to restrict a tuple with another like tuple of different dimension, something like this. They are in equal types. You cannot unify them.
You mean because the tuple can have a generic inside or something like that?
Yeah, that's the thing. That's why I mentioned the list was useful because you can go
But
checking like in a.
isn't that just like a recursive call to the thing?
No, you can't, dude. That's the thing. You always end up with a recursive call because you want to constrain to the case where you have a t variable, right? The
Okay,
problem
you
is
mean
when you don't
because if you
have the
are doing
list.
like pair, people and such, you have like to do these different cases with.
Yes.
Okay, but that's
No,
a
but wait, let me
non-problem
finish.
for
The
the.
problem, it's not really a problem. I'm just saying The hard case is that, okay, you need to call recursively, but you need to compare all the types and see how which one of them behave, and recall like this thing for each independent type. So for example, in a like a in this tuple, right? You have two, a tuple of two, whatever.
Again,
In a sorry.
I just want to know, are you saying that having the types as much as you did like with the T arrow, like you had the from and the to inside the list, are you saying
Mhm.
that having the types inside the list is useful to have that sort of representation?
No, I'm just saying for what he was making, it was useful because he was just handling all of them
No, no,
in
no,
the
no, no.
same
Yeah, yeah, yeah.
case.
No, no. But that's fine. What I want to know is, do you think that having the types inside the list would
Hmm.
help us to do type inference?
No, I just thinking if we have a better alternative for when we do type inference to not handle all the monstrous cases, because I think there will be a bot.
I get that.
No, but that's my
Yeah,
no. Wait a second, Marta. That's my question. If we have a list, would it make it easier?
I don't know, man. Not sure. It would. I think it would, but we
Because you
already
need to
did
remember.
everything without lists, so I don't think it would on the other part of the code.
Yeah, but remember that if you want a list, man, you just have the enum and the bound, and you have the list of the things.
Oh, that's true, dude.
So
Oh,
wait,
dude, what the heck, Lemus?
wait. I'm not
Oh no, no, no,
getting
no,
why
no.
do
Wait,
you need
wait.
that?
No, but
no,
wait. Then there would be a list of the types
yeah, all of them.
of the thing. No, but dude, like, is it like, for example, an arrow? How do we get this as a list instead? That's the point. Like from and to here. You see the issue? Like
Oh, you
Wait,
want to
these,
have lists inside some of those
not
guys
really
here.
I
inside, like
get that.
literally
Let me
this.
go
You
real
see?
quick, man, because I think that the thing you are talking about will already happen like anyway. Because, for example, at least the way I saw that we can do like tuples of arbitrary size, records, and some types, they all involve lists. So what it looks like for me is suppose you have like you are doing the unification, you have the left side, you have the right side, and well, let's suppose the left side is like a tuple, right? So it
Mm-hmm.
will be like a list of types. Some of those like will be generic, some
Mm-hmm.
others will not. And then you literally just do like a unify on like both lists, like on both sides, right?
Yeah,
And
but that's the thing. Like you need to check that both sides are equal.
yeah, that's just going to the list, unifying them. If something
Okay,
is an
if
error,
you're handling everything as a list, it's easy. That's what I'm saying.
yeah, so we don't have to change anything. Tuples are represented like that, some types, records.
Yeah, but we're not representing that like arrows. We're not doing that. For alls, we're not doing that.
Let me see. The case of the arrow, I guess it's trivial. You just recurse on both.
Applications, like for example, how do you compare an application to be equals to other? Okay, it's easy, right? You just pick the two types on the two things, right? In our case, we will have to reduce probably or do
Yeah,
some
we
other
will.
bullshit.
We will.
The for all.
Like, I guess that we will not, like, in practice, not will ever, like, go into the case of the application because we will check if the type is, like, well formed. And if it is well formed, then, well, then I guess it doesn't have an application anymore, right? Because it will be reduced and yeah, you will never have an application that is not reduced to factors.
But you need to restrict. The only thing you need to check if it's the variable has not been, if like you have a generic variable that has not been restricted yet, right? If it is restricted, if the type conforms, that's the only case I think.
Yeah, but let's like continue with the thing and then
Yeah,
we
let's finish this first. I can tell we are gonna spend like ages doing that.
Okay, that's fine. Okay, so after okay, so these are the equality that I made. So for the list, if you have a generic list, everything that matches with that is going to be true. And if you have lists that have a type inside them with the maybe, then you compare just the internal ones to see if they are equal.
Oh, okay. You say anything because it can only be a list, right?
Yeah, no, it can only be a list.
Okay, and if you just compare both, okay?
Yeah, and then the T abstraction info, I just copy pasted from the T for all and change the name.
Yeah, and both are wrong.
Okay, so let's go.
So let's see.
Oh, and
We
by the
were
no, wait, continue.
go first.
No, it's because I thought, man, these are equal. Can't we make one single type to handle both of them?
Do they have the exact same thing?
Yeah, text kind type, text kind type.
I guess you just can.
Yeah, but that depends if the equality is also equal.
Wow. Let me see.
No, the equality currently is equal, but you said they are wrong, so
No, no,
let's
no, no.
fix that.
I'm taking a look on the.
Oh, okay.
They are literally the same.
Okay, so we need. Oh man, that's gonna be hard. We need a name for both. Uh,
What do you mean? You have like a variable name, parameter, whatever. You have a notation. You have a body or return type. It's the same
annotation.
naming.
Annotation info.
Oh, okay. You mean the name of what will be there?
Yeah, yeah.
Oh, I don't know. You can call abstraction. Like both are abstractions.
Okay. Actually, I'm dumb. Let's go back. Oops. I did
I guess
something
that
wrong.
the info doesn't give you any information, man.
It
Like
doesn't.
every type is an info.
Oh, but this is the guts of the thing because this thing is just a pattern to pattern match, right? And this is what
Yeah.
matters.
No,
Uh,
but what I mean, if you for how can I say? For every internal type that you have like this, you could like append info as the last thing.
no,
Because
of
well, they
course.
are like max info. So if you can do that for all of them, then there is no point in doing for anyone.
No, but like I said, we are using the info suffix just to portray the meaning of, oh, these are the internals of the thing. That's what we are why how we are using it. But anyways, then we can nuke this other thing that I just copy pasted here. We can just remove it. And this guy now is abstraction. And this also. Okay. So what is the equality?
That is something funny. Go to the book and look at the type equivalence.
Oh, here.
So see the last one on the left.
The last one on the left. So this.
Yeah, like what the fuck? Oh, okay. He's just saying that. Uh, he's just saying that like the reducted type is equivalent to the non-reducted type.
This is an abstraction, right?
Hmm?
Yeah, this is a function that expects something with this
That's
kind.
an application.
No. I'm highlighting just this.
Oh, I was not taking a look at screen. Yes.
Okay. And then he's applying this, right?
Mm-hmm.
Yeah, I think this is like, yeah, this is equal to this. Yeah, it makes sense, but.
Okay. Yeah, I guess that is only well, not to tell us, but I guess in our code that only enters as will you normalize both types before like comparing them. Maybe that's it, right? And
Yeah.
the application you can see like it's just like recursively the for all and the abstraction like yeah just the same, and you can see that they're saying right. Oh, check if the body is the same,
Wait, I'm
but
confused. Is this the T abstraction?
yes.
Wait. Why do we need to make it separate then?
What do you mean?
Yeah, because in the code we just created, instead of like T abstraction being a text, a kind and a type, because you said the equality is not trivial, so we can derive it. But I don't know. This seems to me that it is doing
Yeah,
that.
that was I was about to say. Even though he's showing there just comparing the body, I guess implicitly there, he's saying that the kind is the same, and well, he's probably also assumed that the binding name is the same because,
Yeah, no, aside
like,
from the binding name, the deriving would be enough.
yeah, but the binding name is what makes us like do a special check.
Yeah.
So
Okay,
go back
so
to the book just for us to go up and
okay.
be sure.
So this is
Like
the
the
phone, right?
arrow, the same, yeah,
The same
the
as this.
arrow, the same, just like recursively.
Yeah.
Those three there, I guess they are just stating like properties about the thing, right? It doesn't really matter for us.
Yeah, this is the what is the name of this man in logic? Symmetry, yeah. Okay,
And the
good
other
to
is
know.
transitivity or something.
Good to know.
Like, yeah, it doesn't really matter truly.
Yeah, and this is transitivity indeed. This. Okay, so
Yeah,
let's go to the code then. So how you do it? How we are currently doing? We compare the kinds. If the kinds are equal, then we compare the identifiers.
yeah. Let's like put that on a hold and let's do the tooling for that. Like starting with substitution maybe, because we need substitution for
Oh yeah, it's here.
implementing this.
I think this is wrong though. I think the type should come first, and then the answer is true. But
Oh
okay,
yeah, would be like really nice to check the kind, and if they are wrong, you already like exit, right?
exactly. Okay, so type
Ah,
substitution.
yeah. So we have like placeholder,
Yeah, let's
type,
just
and start.
yeah, we need to remember what are those names because we couldn't make better names.
Type prime is the worst one of them, but
Yeah, I agree.
I don't know which one would be
No,
better.
no, no.
I
But in
guess
That's
Natanz this is this man, so it's the same. So
no. He's not complaining about like if you are using underscore or prime, but just saying
yes.
type it's shit, right? Like placeholder, I guess is okay, and target maybe, but type is what we want to change for, right?
yeah,
Uh, I was usually using two.
Candidate. You
yeah.
gotta think
Candidate is
of
fine.
you gotta think of corporate candidate.
Yeah, I was thinking that this sounds like Microsoft. Uh,
Just think candidate of a delegator could not be restrained. Please apply an interface iSerializable.
like, can we relate something with target? Like, is there something that makes sense relating with target? Like, target is the type that we are substituting in, and what would be the name that we would substitute for? Like,
I don't know. I think that we can go with your thing with the tone to and from. Oh,
no,
and
no, that doesn't
it's
make
from
sense.
and to actually. Yeah, it makes because
No. The
this is
from would be the placeholder, Lemos.
wait what?
Yeah, from
No, no. You
placeholder
want to
to type.
substitute you want to substitute this guy with this, right?
No. Take a look. From placeholder to type in target.
Wait,
You
repeat.
want to go from the placeholder to the type in the target.
Oh. Oh, it's easy then. So to from within.
No, it's the opposite, man.
No, you want to go from
It's
this to
from,
this inside
yeah,
this, right?
yeah.
So it is what I said. To from
No,
and within.
no, it's from and then the to.
Oh, from to within. Okay, sorry.
Yeah, you don't need to put the within, but well, we can use this or whatever. We need to implement the thing.
Okay, so let's start with the easiest ones. So are those? Those are the easiest
Yeah,
ones.
yeah, the ones that don't have like shit inside,
No, no,
they
this one
just
has shit.
return themselves. Yeah, the first ones. Yeah, the list. Oh, dude. Oh, okay, this F map. Oh, that's not a list of types, man. That's just one type, right? The F map is like go inside the option, right?
Yeah.
Yeah, list there, bad name. No. What? Oh, okay, yeah, we have the new thing, right?
Uh,
But you don't
Oh, and
need
we
to
also need to do the
disconstruct.
nothing, man. We forgot.
No, no, no. You don't need. No, no. You don't need to disconstruct it. Just your F mapping issue. If it's like none, it will be none. You don't need to handle two cases with the F map.
Okay, so this is the I don't know.
Like that's the info, right? Oh no, no, info no. That's just like type, right?
Yeah, so this will be the list type, I guess.
Okay.
So then you apply substitution inside this. You want to replace every single appearance of this with this.
Yes, yes, that's correct.
Yeah, and then the F map. Okay, that's how that works. Okay, so the easiest ones, they're done. So let's go to the
Okay.
complicated ones.
Well, not really complicated, but
In comparison, they are
yeah,
complicated. T arrow.
yeah. We
Recursive,
just
recursion.
recurse. Yes. The
Uh,
first one's parameter, the second is return type. Okay.
yeah.
Application, the same, I suppose, right?
Yeah, application, we the same, just recursion. And then the abstraction, right? So if you have a type abstraction in which the label, right, the label of the type abstraction is the same as the placeholder,
Wait, one moment. Dude,
what?
uh, like this is matching the time. Dude, maybe what we were aiming for. Oh, okay. I guess we will do the following now. Uh, as we are not in OCaml, we cannot like match. Oh, dude. Yeah, what we are going to do is the following. You match on like either T abstraction or T for all. You get the info inside, and you call a function to do the substitution on the info. Because then you'll be the same function for both infos. So in both branches, you just call one function, and that's it.
Wait, can you repeat the last part? You want to make a
Yes.
function to abstract out this behavior, as far as I understood.
Yes. So in both T abstraction and T for all, you have some type inside that they are the same, right? In both cases.
Yeah,
So in the branch of T for all and on the branch on T abstraction, you
yeah.
will just call a secondary function on like their infos, right?
Okay, so you want to make like an abstraction substitution or something like that.
Yeah, exactly.
This thing will receive a type and it will return a
No,
type.
no, it will not receive a type.
It will not.
It will no, it will receive the info, right? What is the type of the info?
This.
Oh, I
Structure
see
info,
what.
right? And then this thing, the same rest, like we need the from.
Yeah, but how are we gonna know that you need to wrap with the abstraction or T for all?
Yeah, we. That's why we have like the two branches. We are just mapping the inside with that function, right? As we are in the T list.
Oh, I see what you mean. I see what you mean. I see what you mean. Okay, so what you're gonna do? You're gonna better match this guy.
It also needs to return the abstraction info then. And we are like missing some stuff, right?
We are
So for
missing some
example,
stuff.
we still need the from and the to, I guess.
Oh, that's true. So both of them are types, right?
Yeah, you receive
No, no, no.
no, the
It's
from is
text
a
and type.
text.
Text and type.
Yeah, so we have the from, the to in the abstract info, and then we return the abstract info. I guess that sounds right. Then we have
Yeah, so
label,
if
kind.
the label is equal to the placeholder, well, with the from,
Yeah,
then
first I have like some bad news that I think I should have told you before.
here it comes.
Can you go on our like?
I
We don't
have
have.
bad news.
Yeah, we don't have like those substitution and sheets for evaluation, right?
No.
Okay, yeah. Can you go on our type AST or type ADT? Yeah, where is the T var? It's text. Yeah, dude, like T variable. Uh, Now, easy way to implement substitution and shit would be making an ADT instead of text. An ADT that we can put either text or some generated ID. because
I'm not
that way,
understanding the why.
yeah, the why is because you need to rename some variables to do the substitution, right? So you need to pick a name that is not like chosen by anyone. So if you are doing that with strings, well, I guess you're never safe because the user like can kind of always type that name. Otherwise, you have to forbid on the parsing, but then you can have a mismatch, right? You have a dependency between your
Wait,
parser
let's
and
just see
your.
if I understood what you said. So what you're saying is that we will need to do some swapsies of strings, but
No, well,
okay.
kind of.
Well,
It's a
what is it
swap.
saying is adding a label like an identifier, a unique identifier to a string, right?
Yeah.
So we can identify and separate by context what the user is typing
Yeah, no, but I
when
want
he
to
wants the
understand
same
in which
variable.
situation
Okay, so
this
Lem,
can happen.
yeah. So if you go on Wikipedia and look for lambda calculus, because there they like have the rules like pretty nicely.
Hmm.
Okay, and look for capture avoidance substitution. Like I think it's on three. Yeah, so you
Oh,
have the
this is
rules
what we
now.
were talking that day. That you already forgot, I know, but we talked about this already.
Yeah. So in one of the rules, like the last one and shit, uh, you have to rename abstraction, and it needs to be a fresh name, right?
Yeah.
So the easiest way is just for you to generate an ID. Then you don't have to like check again and again if the generated was already in the thing. You don't have to like go on and on that. You just generate a unique thing and you know it's right. So an easy way to do that, the way I saw someone doing, is the variable can be an ADT. There is either a text, that's what you are going to return from the parser. But then when you need to rename, then you will change that by an ID, right? And the easy way to do an ID is just to do a counter. Because, well, you know that you never repeat, right? Because you are increasing the counter. And you still save us the information of what was the original name as a string, as metadata, right?
Okay, so it's kind of like t variable text in an integer or something.
It needs to be an ADT because we will not like return an integer when we are parsing. So there needs to be a case in which is only text.
Oh, okay, okay. So it needs to be an ADT. Yeah, that's some bad news, but we can tackle that later.
Yeah.
Let's continue doing this thing here. So
Ah,
uh, if the label is equal to the from, in both cases we are just returning like wrapping and getting the same thing. So I think this is abstraction then. And then
yes.
else what? Else we call type substitution again. So ooh wait.
That's the case in which you need to refresh
No, yeah,
the
but now we have a
label
problem, right?
and then doing the renaming and then doing the substitution.
Wait, can you repeat that?
Yeah. So the first case is the shadowing, right?
Yeah.
Uh, so if the shadowing is not happening, then what we should do is to get the label, right? So the variable, we need to refresh that. So to change for a new identifier, like preference a unique one. And then with that, we rename the whole uh, the whole type, right? Like we change the old variable for the new one. And after that, abstraction info will be have like renamed, right? It was often renamed. After that, we can do the substitution that we really want to. That is the from, to, in the new renamed thing.
I'm having a hard time understanding what you said. Because you said in the beginning that we need to rename it.
Yes.
We rename. How are we gonna rename that?
The way you rename is to pick in the label,
Mm.
right? You pass that to a refreshing function that will return you like a unique variable, right?
Yeah, that we currently don't have that function, but okay, go.
Then on the type, like the body of the abstraction info, you will do a substitution on that, looking for
Oh,
label
okay. So
and replacing by new label.
okay, so this is okay. So you're gonna have a let here called new label, and then refresh label. Then we do an in. Then we pick. We use the new label here, the same kind, but we call type substitution with the place with
Yeah, don't need no no. Do the following. Just put the new type body in a new let.
the new type body. Okay, so the new body here.
Yeah, the
This
new
is
type,
calling type
right?
substitution.
Yeah, it's called type substitution on type.
Yeah, but what we're
From,
gonna replace? The new label,
from
right?
label to new label, right? But new
What?
label, yeah, from label to new label.
No, but that doesn't make sense because new label
That's
is
the alpha
text.
renaming. No, no, yeah, but then you just wrap in the variable, right? To be a type.
What? I'm totally confused. The
You
type
wrap?
signature of
Yeah,
type
I got it.
substitution is text type type. We need to have a
Yeah.
text and two types here.
Yes, and then he's saying wrap in a type variable.
Oh, so he's talking about doing
Yes.
this?
Yeah.
Uh,
In type, right? And then you can return. Wait, oh no, but well, I guess it doesn't matter because of laziness, right? But you are doing this before checking the if, right?
oh yeah.
Yeah, but I get that laziness saves you.
Well,
Uh,
no, actually no. We could do it like this, and then where, and then that.
okay,
Yeah, that works.
and then the return. Oh shit! Can you format that?
Oh, I don't have
Okay,
the Emacs shortcuts. Okay.
so okay, then the abstraction info will get the new label, the same kind, and the new body, but now we do a substitution on the new body.
Oh wait, now you're talking about calling this function here, right?
Mm, no, on line 23,
23. Okay.
you have the new body, right?
Yeah.
Let's do a substitution on that.
Again? Oh, but
Yes,
this is
again.
just a this was just a gambiarra. Okay.
That's not Gambiarra, dude.
No, it is because we are reusing this function and wrapping with a t variable in order to just do a replacement procedure.
Yeah, that's the alpha renaming. So that's not Gambiarra.
That is. But okay.
No idea what you mean.
We're gonna replace what we're gonna substitute.
Now it's the time the from and to.
Oh.
Yeah, that sounds more like a proper a proper substitution.
Substitution.
Now you can fake implement the refresh, right? So
I
just so
have
that's
I have no idea how we're gonna do what you said
ID,
because
dude.
yeah,
Like
but no, ID is not easy because that involves a global state.
no. I'm saying faking implemented ID like identity X to X. Just return the same. We will implement in the future, but you need to change for IDT, right? And
Yeah.
the part that is tricky is regarding, well, I use mutability to do that in Okama, right? The
Yeah.
counter.
That's what I'm not
But
gonna. And I know.
a better
I'm
way
gonna have to think how to do
is,
that.
yeah, a better way is if you actually pick up. function that generates a random number,
No, but that
like
is
the
easy.
ID. Then we can do that.
No, but
Yeah, but
then
like
there's a
it's not
chance of
guaranteed,
yeah,
right?
exactly.
It's not guaranteed.
Unless
The
unless it's
counter is also not guaranteed because we are dealing with finite integers.
yes, but dude, like okay, like if we it's a big random number, I think it is the same guarantees we're having with an integer overflow.
Like in a code, you don't pick like a trillion variable names and need to rename all of them, right? So the chance of clashing is not high, dude. Like people use this for more like better uses, right? Of like random IDs, but
No, I
still the
guess.
unique ID.
I guess.
The abstraction. Uh, the abstraction label kind. No, wait, dude. I guess you're calling it wrong, Lemos.
Where?
Uh, yeah. Uh, you will like the abstraction,
Mm-hmm.
and what will be inside will be the result of a function call. A function call to abstract substitution, where you pass the from, the to, and then your info, right?
Yeah. Abstract substitution, the from, the to, and the where.
Yeah, so why do you have the label and the kind there?
No, because this needs to return abstraction substitution doesn't return a type, right?
It's return abstract info, so why do you need. Wait.
Oh no,
Yeah, I don't
this
think
is
you need
this is
label and
this
kind there
is this. Sorry. And then you need to do the same stuff
for the
for
for
the
all.
for all. It is kind of the same. Yeah, and then you can get rid of all of this. The for all placeholder.
Yeah, and then you don't need to deconstruct anything, right?
Oh yeah, I don't need to disconstruct. You're correct because we're not gonna use it in outside here in this scope.
Right, prime.
Okay, last one is the t variable.
Yeah, that's the nicest one, right?
Okay, so if the identifier is equal to the placeholder, we just return the type.
Otherwise, itself.
Yeah.
Sounds right.
Okay, now we can go back to equality. Yeah. I am guessing that this shouldn't be here. This one.
It actually should. Because if they are already equal, we just check, right?
If they are already equal. Oh, okay. I see what you mean. If they have different equal names, we can just call type substitution.
No.
Uh,
If they have equal names, we just call what we are doing. Then type 1 equals type 2.
wait. Oh, okay. If they don't have this case is in the case in which they don't have the same names, but they may have the same type.
Yeah. Well, after substitution, right?
Yeah.
Yeah. So okay. So the way you do it, you can pick like ident1 and refresh that. Yeah, that's a good thing. We could also like encapsulate some stuff in. Oh, I don't think you can. Yeah.
What you want to
Okay.
do? What you want to do? What do we want to do
Okay.
this equality to do? What is the behavior?
Okay. Wait. Else false. Okay. Yeah. So on the your like line 84, what you need to do is to refresh ident1.
Why?
Because you have to drop or rename both to the same name, and you just cannot do what we are doing because this could bring a clash. Let me show you a quick example. Uh, Good. Substitution like has a lot of pitfalls, like a whole ton of pitfalls. We are probably still doing something wrong here.
Yeah,
You can,
probably.
you
He's
can be
probably
sure
still
of
doing
that.
something wrong.
That's why people use that, like the brow instance that we were talking about, Lemos.
Hey,
Oh, I know what you're talking.
you said the name correctly.
I'm not sure if it's correct. I'm
The
not sure at all.
pronunciation said to be brown.
Who?
No, I read somewhere that the pronunciation was brown,
Well, yeah,
not bruin or something. I
yeah,
don't know.
I'm not sure.
Dutch is like
I would not vouch for any of those.
Dutch is like literally the seams language.
So, okay, I'm sending on the chat. So, let's suppose you have those two functions, right?
Okay.
And you have mm, this. Is this correct? Um, wait, those. Uh, and what you want to do is to replace the. Oh shit! I guess I forgot the example. Ah, yeah, but there is a situation if you want to pick the name of one and do the offer rename with that in the other, it fails. I guess it's the case where you want to pick the X and you want to offer rename the other with this X, right? Because then he will be doing from I to X in the like the second function, right? He will substitute the name for X and everything that is in the body from Y to X, but there is none, then they will become the same, even though they were not.
I
Did you
think you
got it?
told me like this problem in that day that we were exploring the other mechanism to alpha renaming crap. I
Maybe.
remember you saying something like that. That oh, if there's nothing in the body and then you rename it, then one will become the other out of nowhere.
Yeah, so yeah.
I don't know how that's related to what we're doing right now here.
No, so you see that we have two different functions on the chat. Can you paste on the VS Code?
Oh, you mean the in the chat that of the voice channel?
Yeah.
Okay, so you're talking
Oh,
about
you were just listening to it? No,
I
no,
just
what the fuck is this? No, no, where we are right now, like the last message.
oh I I was like days behind. Ooh, sorry, I lost the con the con the contour stuff. Here.
Okay, so let's suppose we have those two functions and we want to compare them, right?
Yeah.
So since they don't have the same variable name, right? The same binding name, we have to auto rename them, right?
Yeah.
So a naive way to do how we are doing would be to get the name of the left function and rename the second function with it.
Yeah.
So doing a substitution from y to x and changing the binding. If we do that, they will become the same function, even though they were originally not.
Okay, so what is the proposal to that not to happen?
The proposal to that is to get the name of the left function, do a refresh on it, and use that to substitute in both functions. Then we can compare
Oh.
them.
Oh, okay, I see what you mean. I see what you mean. Okay, I got the problem. Did you get the problem, Agata?
I wasn't paying attention. Sorry.
Okay, so do you see these two functions here?
Let me see. Yeah.
Yeah, so do you agree that if we go to this function and pick the label y and do an
Oh, I
alpha
see. See.
to
They're
x,
gonna
then
replace. They're gonna be the same.
they're gonna be the same, but then they shouldn't be, right?
Hmm.
Yeah, so that's the problem. Okay, so let's make the refresh function, which is
Imagine
refresh.
wait, but you already have it.
I don't.
Wait, didn't you implement the idea? Oh, okay, you are implementing. But imagine we following with the project with all of these wrong men, like. would be hell to debug anything. We would have no idea
No,
why
we are
the
not
thing is
done. We are
failing.
not done. We still have to do reduction.
No, yeah, sure. But you know, right? Imagine we just going
Oh,
with the
I could live with the bugs.
program. Oh, dude. I guess you could, right?
Huh? Don't know why you guys are so baffled about this.
Imagine using Haskell and Haskell itself having bugs. How we would know if it's on our program or in Haskell?
Yes, exactly. So you just leave the carpe diem
It sounds
lifestyle.
fun, right?
If you don't, if you're not doing exception stuff, it's fine. Okay, so reduction. This is the
No,
final
no,
thing.
wait. Did you implement the thing already?
What do you mean?
The equal
Yeah,
for
yeah. Here.
that. No, uh, that's not what I said, dude.
No, you said
Uh,
pick the identifier from the left and refresh it.
yeah, that was the first phrase. So after that, you pick that refresh variable, right? And do the substitution on both functions, bodies, and then compare them.
Oh,
Like that doesn't do anything for us.
type substitution in this side also.
Yeah, but you need a let for the refresh, right? Because they need to be like substituted for the same new variable.
Oh yeah, you're right. So let new label refresh ident one in. Uh, then what I'm gonna do, I'm gonna pick the first one, t variable new label
Okay. In the first type one, right?
in the first type one, and then you do the same thing in here.
Why is that all yellow?
No, it is because this is, can be reduced into another crap.
Okay, so type substitution on the indent one for the new label in type one, and type substitution from indent two for the new label in type two. I guess it sounds right. Yeah,
Yeah,
yeah, I guess we're done.
yeah, okay.
And what is the least failing?
No, it is no, it
Not.
is because it is suggesting to use a new type because this is not a sum type. But that's just like minor details. So let's go to the reduction.
Yeah, is that the last one?
Yeah, this is the last one.
Oh,
And I'm assuming, I hope Magetta remembers this because I totally don't. I'm assuming that we already checked the place that we should do reduction in here. I remember we had a very long conversation, and then we discovered the fish and stuff and blah
I
blah.
guess that, I guess that you check it everywhere when you're doing the type check.
Yeah, we
But
checked. Yeah.
otherwise, it's easy. Like every time you're doing matching on a type, we need to reduce first.
No, we are doing that like every time we are type checking. No, not every time, but most of the time we're doing type checking, we are reducing immediately after.
Yeah, every time it might be a
No,
problem.
not every, like in here, but in a lot of cases. Um,
Yeah.
yeah,
So
if you
in
see
the
here,
future,
type checking, reduce. Here,
yeah.
type checking,
So
reduce. So
yeah,
I
I
think
guess
we already
that
checked.
yeah. Otherwise, that's just easier to check in the future.
Okay, so
Yeah. So the
reduction.
first thing I guess we can do, yeah, I guess we can just get rid of the infinite.
No, but oh, because this is a hack. Okay.
Yeah, it's a bit worse than.
Okay, can you explain again why we needed the env and why we're not gonna need it anymore?
Uh, yeah. So it's because we are doing substitution and our substitution was flawed. And that was
Oh, that's why we're applying renaming here then.
Rename?
Yeah, that's why we are refreshing labels and stuff. Because as far as I remember, the reason why we were having to have the environment is
Oh, to
because we
be
want.
clear, it was not a free variable there.
Yes, exactly.
Yeah.
Okay, that
And
makes
I,
sense.
yeah.
Okay,
Yeah, but
okay.
the thing is, maybe like that hack, as you said, maybe it has a, a plot point somewhere that we are not like we're
Yeah,
not aware.
yeah. It's complicated to know that. But the first thing that we need to do is do a Control F and then reduce type env. Needs to be just reduce. Replace all.
It's both.
It's easy to get back if you make a mistake. Okay. Okay. So yeah. Okay. So with that removed out of the way.
Yeah, what's that a neither?
Yeah, that's an either because you can have an error here.
Yeah, that's not a neither anymore.
Oh crap. Man, the binds in here. Ah, no. So fucking sad. But
I
okay.
gotta actually agree.
So sad. Now everything is wrong. How cool. Okay, let's one by one here. Okay, this is already wrong. This should be just dollar. Next, I should have reduced type in my stuff here. Let's go from the first one. Next one.
Is it dollar though?
What? What? Sorry.
Is it dollar or is it composition?
Dollar. It's a dollar there because we want these two things like these to be applied to this, and then this finishes, and then we reduce it.
But that needs to result in a function. I think it's composition now.
Wait, you're correct. This needs to these all of this needs to be in a function. I think it doesn't matter because you're gonna put a dot here, but then I think it will understand like this.
No. Like function application is always the most priority.
Function application. Oh, okay. So what you're saying is that this is enough. That's what you're saying.
I guess so.
Uh, I actually don't know. For me, it makes more sense to be a dollar, but let's go with your composition. Next. Okay, these are the boring ones because Mageta is not helping me today. I need to do this by hand.
Oh man, let's see. Let's see what you're
Here,
bitching about.
here.
Let's see.
Ooh, fancy. Next.
Mm-hmm. So what you doing now?
We are. What we are doing now is we are going to each place that in which we have the reduce type function because it wasn't either before, and now it's not. And that had a side effect that every single
Oh,
place
I
that we are
see.
assuming it is an either, it is not. So yeah. So I am going one by one here, changing it back. Yeah, next. Those two here. This can't be a bind anymore. This needs to be this. This also.
Oh man, it's so sad.
Yeah, removing the fishes to put other crap. Oh, this is wrong. This is wrong. This needs to be fmap. That first case, Nathan, is also wrong that we are talking. Because this returns an either.
Oh, it's true. Oh yeah.
Uh, yeah, this is a let, another let, more let, fmap.
Wait, but you are f mapping a function.
No, I'm not fmapping a function. I am fmapping a function. Yeah, that's correct.
Wait, isn't the bind then?
No, it's not the bind. Because what is the type of this? What is
It's
the
a
return type
function
of
that
this?
ex
No, no, no.
is a
What is it?
function that
This.
man, that's a function that expects something. Like expression, I guess.
No, no, no. But that will come. That will come from the list here. So this.
No, no, dude. This thing between parentheses will result in something that then the for will take. So, right? The for will not inject a thing there, and then we will evaluate the reduce and shit.
Can you repeat that?
Oh.
Yeah. So you will evaluate where is between parentheses, and then pass that resulting function to the for. The for will not put a
Oh, it is the
third argument
same.
there,
Yeah, it is the same problem that we had with the fish because it needs to have crap here and stuff like that.
or not, if I guess you use the bind, right? Oh no, the bind also requires to be already like done, right? To be
Okay,
past
so
the argument.
HLint is suggesting something fancy.
Reduce and then compose fmap reduce type dot, so compose, right?
Yeah,
With
so
the type check.
Oh, that makes sense.
does
Yeah,
it?
it does, because you see the
Yeah,
compose that I said before, it was not working because it would be an either, but you are mapping it.
Oh, I see what you mean. Um, yeah, that's not the case in here because here we don't have a for. We have the full stuff on the right, including the expression. So this can be fmap just okay. Uh, but there's another places in which I did this with the for. Just a moment. Yeah, here. So this needs to be an fmap with a compose. But what's the flow of the data? Can we go through that a little bit? Because this will pick NA coming from that. It will apply all of this thing because this is a function. And then it is composing an fmap.
Yeah, so you will type check whatever the for gives you, right?
Yeah.
And then you fmap with reduce.
Yeah, I'm not seeing what this is doing because I never saw fmap interacting with compose before in this manner.
Uh,
Uh,
like what fmap, like what, okay, fmap reduce.
oh, this is
What
a
does that
function.
returns?
Yeah, this is a function
That
that picks an
expects,
either and returns an either applying this function in the middle.
yeah.
And this is a function that returns an either after receiving some stuff. Yeah, that makes sense. That makes sense. Yeah. Also yes. Yes, 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 yes. Okay. Okay, we got rid of the either also. Next.
Oh, dude. I even forgot where. Oh, okay, we didn't even mess with like the thing yet, right?
No, we didn't start reading it yet.
Oh shit. Well, now we don't need do and stuff, right?
Yeah, we can't have do actually. So this in same thing for this guy because now you only have a let, and then instead of that we're gonna just do in, and doing that this guy let.
Oh, that's so sad.
What is said, dude?
Uh, I get
Here.
that.
hmm?
Uh, Like I just saw yesterday that things can go much more complicated than like we can think of. I was doing some lang using like substitution bullshit, right? But it was so fucking like, well, kind of disgusting in many ways, the substitution, that I try to do in the way that we do our evaluation, like using a nav and shit, right?
Mm-hmm.
Ah, Dude, but it's even worse. Like you don't know where things can fail. Like, well, the thing just grow like complex and complex and complex. Like it's ridiculous.
Agora take a look at what you're doing. I can see.
Yeah, I can show you later.
No, you try to replicate what we are doing in other language. That's what you tried. Hello?
Wait, can
No,
you?
I think I was doing dependent types.
Yeah, so that whole thing about laziness that I told you, Lemos,
Oh, okay, I
it's
see.
because like for type checking, I have to evaluate stuff, but I don't want to evaluate my whole program, only the parts that I will need to type check, right?
Oh, that's why you need laziness there.
And also, I would ideally like to ensure that the things that being evaluated on the like annotation, they are pure, right? I'm not like printing stuff
Yeah.
during like compilation.
Yeah,
So
that sucks.
that part I thought it would be like easy, but it is not because I was thinking, oh, I will add the IO monad, and then it's okay. Like the type just can't be IO there
Yeah.
on the result, right? But that doesn't work. Why doesn't that work? Because I can do a function that picks IO and return whatever. So the argument will be evaluated, printing something. The result of that goes to a function, and the functions return something pure.
Wait, you have a function that receives something in IO
Yeah,
and returns
but
something that is not IO and it is not a transformer and crap?
because I'm only receiving as a argument and not using it, the IO.
But you are making your own IO. Yeah, that's what you're doing, right?
Uh, so let me give you an example.
No. We can talk about that a little bit later. Let's just finish the reduction thing. Okay, so let's go one by one here in the reduction. The reduction, it was environment to type to either, and I was just type to type, which means that these pures are wrong.
So yeah, like uh, just return itself, right? Sadly, we can make. Oh wait, the list is not elements, right? The
Uh,
list is like one type.
yeah, this function that you gave an example, this you can't make this in Haskell
Oh, why?
because it needs to because the return of print is IO.
Yeah,
Yeah.
then the function is taking the IO.
No, wait. You are defining an x. X is a function, right?
No, no. This is a function. X is the parameter of it, right?
Wait. This is a function. X is a
That
parameter.
takes X, that is IO unit, and returns integer.
Yeah, that's the
That
thing.
is, I guess that's a problem with being strict.
No, that's a problem that, as far as I'm aware, if you have like in the type signature something with IO, you kind of like you pollute everything else with IO. You can't get out of that. Out of
Even
that.
if your argument is taken an IO type, like
Yeah.
that would be nice.
No, I'm not saying it wouldn't be nice. I'm saying that as far as I
No, no,
can
no.
tell,
I'm saying that would be nice for me if Haskell does that way. Then I can copy and get like easily a pure annotation. Do you know where I can like look more about that?
yeah, I'm just saying by via my personal experience. Every single time I even made jokes with Breno at the time, saying, man, at the point that you introduce IO anywhere, everything gets screwed. Be-
Yeah, but Lemons, I know that okay, if I want to get a string from the user, then the type will be string IO, and since you need to manipulate that, all of it will be binding, and the result of everything will be IO.
yeah.
But that doesn't say for this case of being an argument that I don't use.
Okay, so you have an argument of a function which involves IO, but you're not gonna call it.
That it is IO. Like the print is returning IO unit, right?
Yeah.
I take that as argument, and well, I don't use it, right? I will not bind X.
Oh, okay, but that will still print, right? Is that the problem?
Yeah, that would still print. That's the problem.
Yeah,
The
yeah.
type of the whole thing is int, and I will have printed
No,
something.
no, but that's the thing. IO
That
overrides
sucks.
the lazy behavior in Haskell at least.
Oh, so you would print in Haskell?
Yeah.
Oh, then that's
Well,
feels
I
bad.
never tested this case that you said, but I would say so. I would say. Anyway,
This
let's.
is
Yeah.
unsafe, man.
Huh?
This is unsafe. Perform IO and print.
No, no, no.
No,
But what he
it's
wants
the
is to
opposite.
not print,
It's
man.
uh, yeah, like what I want is exactly the opposite, my kid.
Yeah, he
I
wants the
want
opposite.
for the
I got you.
user.
I got you. I'm just saying, like, dude, just drop this shit, man. Why you bother doing all this stuff? Like, who
Well, because
cares?
he's learning how to do a lazy language. He knows more than
No, I'm
us.
not learning. That's not a
Wait,
learn. That's not a lazy language.
you want laziness just because of
No.
your thing, but you're not.
Yes.
Yeah.
So yeah, the language is strict levels. Like the arguments are evaluated before the function and like the body of the function, right?
No, that's fine, but you are exploiting laziness regardless, which
Yeah,
is
but that has
understandable.
nothing to do with this. Like,
No, but you had to because you just said, "Oh, I don't want
yeah,
to evaluate my stuff while type
like
checking."
everything.
Yeah, everything. Moving on. So if you are a literal, we just reduce to yourself. If you are a list, if you are a list,
Yeah, you need to like recurse, I guess.
yeah. But there is also another gotcha
And
here.
that's not elements, right?
Yeah, that's why I got confused. But it was like 3 in the morning and we were doing this. So t list info, and then here we have the type of it, right? And we need to call reduce type with that thing.
Yeah, like on the arrow, we are not really gaining anything for the lets. We were using because we had to do the do notation, right? But right now, I guess we can just inline, man.
Yeah. Um, reduce type parameter, reduce type return type.
By the way, like, and you see this reduce type, like that we could call like normalize.
Yeah.
Uh, in the language that I'm doing, you kind of can use that for like type checking and for evaluating your program. Like they are the same. They evolve. It's the same thing as like reducing those types. So if for some reason you need a different behavior, well, you're a bit unlucky.
Okay, that's weird, but okay. Uh, type variable we do nothing.
Just itself.
The next one is a T for all. What we are currently doing, we reduce the body type and then just reconstruct it. Yeah, that's what we do.
Parameter name, parameter kind, and body type. Yeah, I guess that's it, right?
And that's actually the same thing with the T abstraction, which kind
Yeah,
of
this
the T
option
for all is
parameter
too
name.
big, but this is fine. So reduce
Yeah, type abstraction.
in here. Now the hacky one. Mm. T application. What should we do to reduce it?
Okay, so yeah, the first thing you do is to reduce the function,
Yeah,
right? And then you can pattern match that.
I can pattern match.
Yeah, you are already doing that. And in the case of the other, it's not an error. It's just returning the same application, but with both things reduced, right?
Okay, so we just return the same thing, the application with the two things reduced. You said.
Yeah, but you already have it, right? Reduced.
Yeah. Oh, I don't need the parentheses. Yeah. So function and argument, I guess. Now
Okay,
let's
but
understand what we're still doing after we match, right? So if we match,
no, but oh yeah, but the first thing is I guess we can just delete the kind thing, the kind like equals there,
oh okay, that makes sense.
Because you can check before like reducing, I suppose.
Yeah, I'm also supposing that.
Yeah. So okay, so in case that's a T abstraction that has name, kind, and body, the type substitution from parameter name or argument and body. That's interesting. The result of that also needs to be reduced, I guess.
Oh.
Yeah. Because you see, like that type substitution can like return something that is not like
Yeah,
totally reduced yet.
yeah, it can.
Is there any other case like this?
I don't think so.
Yeah, maybe we are done.
Okay. Okay.
Are we done? Like done?
Yeah. As far as I can
Totally.
tell. It's
At
not
least
compiling for
as
sure
far
because
as
I
we know,
changed
right?
types. I changed name of stuff, so it's definitely not compiling. But as far as I'm aware, now if after we finish the compiling errors that we definitely have,
Can do
we
refresh, like if you actually want the thing to work.
uh, okay. So yeah, this is expected. This is expected. So the first thing that we need to do is to go here, and every single time we have tfraw info, we're gonna replace that with this. So how
Let's do this obvious code master.
how I forgot how to do that though. Replace all. Okay, just I think we're just gonna call it a day. Go replace. Okay. Now the list should break because the list got a new constructor also. Oh, and the T abstraction stuff. Yeah, we still have those to go. Okay, let's go. Okay, I know this one. Which line? It's 50. 50, 50, 50. Here. Next.
Let me look at the screen. It's easier.
The same. 118. 118. Oh yeah. This guy got a new constructor also. The same thing applies to you. Oops. Yes. Yes. Okay. 124. This.
Oh, by the way, Lemus, I'm not needing the laziness stuff anymore. Uh, yes, because since I'm using like substitution instead of an environment,
Mm-hmm.
I just substitute like my prints everywhere, but only the annotations we'll call normalization. That's what like would actually like print stuff, right? Like evaluate stuff for you, I guess.
Interesting. Okay. Yeah, but after this, we're definitely gonna have we're gonna have Omega. Congrats for
Uh,
everybody.
Still a faulty omega without the refresher.
Yeah, no, we need to make the random function at some point.
If you had .NET hash,
But don't you have like any Unix related on the prelude or just like random number
No, I
generator?
know we do definitely have random number generators, but I just need to. I never did them like myself. I know they exist. I already watched lectures from that people using them, but I never did it myself.
It's just a function, right?
or we just pick the Unix timestamp and do some crazy random number.
The thing is, I think all of them are probably IO, right? Len?
Um, maybe we're gonna discover that.
Maybe?
Yeah, we're gonna discover that
Oh,
shortly.
that would
Uh,
be.
The arrow.
Oh yeah, T arrow there, definitely.
Okay, I guess that would be a good application for the unsafe perform IO, man.
Maybe. We
We
will
swap the
see.
number.
We will see. You
Imagine having
guys.
to lift a monad transformer just to use
Yeah,
in a map.
imagine the refresh like returning IO.
Cursed.
Oh,
Yeah,
dude.
if we reach a point in which I'm gonna say, oh no, this is too much work to just create
A
uh,
random label.
a random label, then I will consider using the forbidden stuff.
Or a beating.
Yeah, man.
Wait, is it list info twice?
No, it's not
Oh.
info twice. I'm just Greg.
Okay.
Oh.
Alright.
Oh, not in scope. Cool. What is the next step that we're gonna do, by the way? Do you guys already thought about that?
You mean language-wise? Well,
Yeah. We
my
have.
suggestion is to do recursion and ADTs, and then I guess it would be perfect for type inference. Because we
Yeah.
literally we would have like a usable language, man. Oh, pattern matching, of course, because otherwise you can't use ADTs properly.
We're gonna have a usable language because until this point it's not usable.
No, if you don't have ADTs,
CDR
right?
here. No, I understand that, but we already have we already have a filter in a map. That's saying something.
Not much actually.
Ah, that's just
And by the way, it's like
or maybe.
okay, it's kind of barely
Yes.
usable actually because you don't have recursive types. You cannot do natural numbers or lists in the language.
Natural numbers and what?
And lists, you cannot do recursive types. But
Uh,
I guess that should come like after inference and shit because well, we still need to like study about it. And I tried already and was not good.
you tried already. It was not good. Okay, for now I'm gonna just do that. Okay. You still complain not in scope. Am I right typing it wrong?
Let me see. Dude, isn't it maybe go back there
No, it is the T list info.
with a type?
No, it is saying not in scope data constructor. But
Yes, it
that
could be that he didn't find a constructor for a type and
no, but
not
I am
maybe. But then it
exporting
would
it
be a type
here.
check.
No, but that's the thing. I am exporting it.
And you are importing there?
And I am importing it, everything.
Fine, sometimes.
Oh, of course. Of course. Of course. Because this is not
Oh,
a
no.
type. This is a separate thing.
Oh yeah.
Oh, shit.
Okay,
Dude, Haskell looks like more and more disgusting, man.
T abstraction 232.
Like it looks a bit like
Dude, like
Java,
90%.
right? The
Dude,
header.
like our meetings in Haskell, they're like 50% struggling and doing things with the types and everything, complying.
32. Oh,
And then the
this.
rest is like me and Ata bashing Haskell. That's literally
Yeah,
this.
no, but I stopped caring, so you guys can say whatever you guys want. You guys have new magic. What can I say?
Yeah, man. No. Oh, you also have the magic. What they're talking about?
Yeah, no, but
Language
I
man,
am
man.
defending to not use it. You guys want it. I'm the only one
Actually,
safe here.
actually, I'm pretty sure that unsafe perform IO is much more used than magic, man. Like for sure.
I don't know what you're talking about.
Yeah, because unsafe perform IO is for you to do like normal stuff.
No, it's not.
Magic is well, it
Unsafe
is normal
FMIO
stuff.
is used to do libraries. You're not supposed to open the libraries. They are
Yeah,
what
it's
they are.
normal stuff.
Dude, you use for
Normal stuff,
debugging.
yes.
No, I don't. I didn't use it for debugging. Magetta wanted to use for
You have
debugging.
a
Because it
problem
is
because
easier.
yeah, it's like
There's no benefit of not using it. It's like just there.
No,
yeah,
man,
for
you not
debug
understand what you're talking
there is
about.
no trade-off about debugging with unsafe perform IO lambs. No no at
There
all.
is, man. You are putting your type safety crap that you defend in risk. That's what you're
Oh,
doing.
debugging, dude. You just want to print something.
Just want to
You're not
see. I
understanding.
just want to see if the program reached that point, man. That's it.
We are not saying you will be with some hidden like IO in our program for the rest of their life, right? For sure.
Oh,
Where
oh.
can I learn more about the IO lens?
What? Wait. Sorry?
Where can I learn more about Haskell weak
Simon Penton
IO?
Jones. Simon Penton Jones. That's what you need.
Okay, I know his name, but what does that like give me?
Just a second. We didn't tackle this case though. We need to tackle this.
Which case?
The T list info has nothing in it. What is the reduction out of that?
Oh man, you just mapped what is inside, like the thing. You only need one case.
No, wait. No, we don't. Oh, you mean F mapping it?
Yeah, and you need to return like wrapped into list, of course.
We need to
It needs to be
return.
wrapped, yeah.
Oh, it needs to be wrapped. T
We need to see if you're not
list.
forgetting that anywhere, because it would be a disaster if you're not wrapping things. Like imagine normalizing list and you get just the type inside.
That would be pretty funny.
The best thing is the error message, man. Because they would be kind of making sense. It would be
Dude,
the same error message that we have with default when you are passing list int instead of int. Would be the same error message too.
dude, I remember compiling like this, doing this when I was without LSP in .NET, in F Sharp. Like, imagine you waiting .NET to compile the thing for you every time. Because like
.NET is a lot slower.
because some morons deleted the support for like the previous
Or
version of the language.
at
Lost
least it
LSP.
at least it was, right, Mageta?
What?
You said it's faster, right?
Oh no, dude, now there's no comparison. Now it's like way faster.
Like Volcano faster?
I think
No way.
I don't. Now it's
Didn't
compiling
start.
to native code and it has JIT, so it must be the same.
Wait, wait. Oh, okay, yeah. So you are not compiling to native code if it has
No,
this.
I'm not.
You are
Yes.
interpreting the bytecode and then using the JIT to generate
Yeah.
native code at demand, right?
Mm-hmm.
Oh, but wait, how is that like? JIT
They
is
have a
not something
post.
that we do in a week, man.
No, no, no,
Like,
no, no. Dude.
how did
It's
they?
Microsoft, man. Like they pay like I don't know 1,000 developers to do the thing, and they do.
Holy man, like from what I heard, like it's a really complex stuff, man. Like
I
it's
think they were doing that since .NET 6, but and by the way, like if you notice, .NET from 5 to 6, it had already a very substantial increase in speed, and then on 7, it's like flying.
but just imagine, man. Like it's not something you do easily, and then the guys just oh now we have a JIT.
Dude, I remember when I used this shit when it was like version when it was like I don't even
Three
remember
point
like
one, it was .NET Core.
if it was like net standard 2, no 3 point something I think. The names are all screwed up.
Yeah, it's .NET Core 3.1, I guess.
Just
Used imports.
oh yeah.
Oh wait, things in the part. Oh, the import. Right?
Yeah, but this is progress because if the parser is breaking, that means that we are getting there.
I
Done.
don't know about that. Oh, we just have like shadowing and use it
Yeah.
methods.
And by the way, these things that you guys complain about, oh, the import list in the beginning or shadowing, you can disable that.
Okay.
Yeah. Okay. I think Okamo also complains. F Sharp I think it doesn't, but
Dude, OCaml has a problem with warnings. Like they are not
They're
warnings by
errors, they're
default.
not
They are
warnings.
errors by default.
Yeah.
Like that's very bad.
Yes. I mean, I
It's
don't
not
know.
OCaml to be fair. Like it's Dune. Like it's Dune stuff. Like, oh, I'm not sure actually.
No, we can blame tooling. But I also actually think like exhaustiveness checking, that's actually good. Like for example, when I got started with F sharp, when I was first doing the interview thing, was the first time I touched F sharp, and I was like, okay, the code must be right. And then I just had a runtime error, like with a match. And then I was just like, okay, like why am I forgetting something? And then I just noticed that, oh, okay, I'm forgetting this case here, but like the compiler didn't warn me because there was not even warning, man. It was just there.
Most of Omega.
Yeah, but the reason I don't know if it's Dune or OCaml, it's because you don't use the OCaml compiler directly, right? So
Mhm.
yeah, I don't know if Dune is passing like by default the flags to everything with an error, or
But
if it's like this in the
If it's
compiler.
IO, I'm gonna start laughing so badly.
I have a bunch of gem stuff.
Yeah.
IO gem. Like it's worse than IO, like it's some random bullshit.
Yeah,
One
it
problem
is
I
a
have
random
with
generator,
Haskell.
which is the proper way of doing random numbers.
Okay.
Do we need to pass a seed for those things?
Yeah. Well, we have the option. I'm sure they have like.
Uniform
What would be the seed for our thing?
Magetta.
Thank you.
Like you just pass a string Magetta.
Emacs.
Wait, what are the kinds of stuff that we can generate? Because they have like uniform, like what are those?
I think this is this distribution used to generate the numbers, like do you know like normal distribution, like the curve, the graph, and stuff.
I guess
Oh, okay.
so.
The distribution, like T student and shit.
Wait, but that would be bad, right, for collision?
Poisson distribution. Let's use that.
What?
Yeah, that's a old distribution. I remember in
Yeah, you do
statistics.
have one with IO indeed, which is this one.
Random IO.
Yeah. Literally,
A
it's
variant of
literally the
random
easiest one
M
because you just call it,
that
you
uses the
type it, and
global.
then done.
Yeah, and save perform I use this, man, and you get an int. Nothing better.
Yeah. Or an error. And if you get an error,
Wait, you cannot get an error for that.
then.
Okay, not that we know, right? I guess it can
I
always
didn't.
fail.
I don't know how they made this library.
Oh,
I
geez.
think
Dude,
that for now, I think that for
just
now
pick
we're gonna
some
go.
random shit, man.
Yeah, for now we can go with that thing.
So, what is the biggest one of generated values?
I think it's
The
an
one that has the
int.
biggest range.
It is this, right? No, wait. Now I'm confused.
Oh,
Where's
this
the?
integer is.
Yeah, this is the 64-bit integer. Oh, but they also have the long stuff. Yeah, so I think it can be pretty enormous.
Let's just get an int, man. Yeah, let's just get an int. It
Okay.
just needs to be different from string.
Okay. So we're gonna go to where was that happening again? I already forgot.
Refresh.
Types.
Oh,
Types. Here.
yeah. So we need to change the thing for IDT first, right?
Oh, you want to do the
That could
also
be
the type
annoying.
variable.
Huh?
You also want to do the type variable stuff here.
Yeah, like needs to be a new type, right? Yeah, that require more like a bunch of stuff throughout the code.
Oh my god.
Yeah. Do this tuning line. No, oh, no, yeah. This second one should be like a tuple, right? Of int and text, because we still need the text.
You always need the text?
Yeah, because we need to print stuff sometimes.
Does someone want
No,
a
what
server?
the?
Does someone want a server hack?
Oh, what?
A server hack? I found a dude selling by like $200.
Oh, like with R? Heck with.
Oh, you mean the matter
Rack.
enclosure?
Yeah, yeah, a rack. Yeah.
Oh,
It's time. It's time to use
There is a
this, Nathan.
certain
Let's make
wait.
Shoko proud.
Wait,
that.
wait, 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 wait.
Oh, the.
No, no, that is wrong. It's not that what we want.
No, it
We
is. Or
don't.
we
No,
want
no,
only this, or both.
no, no. We don't have the case in which we want only int.
Oh, it is just like oh.
Sadly, that's not the dilemma. Just use a
No,
tuple,
but
dude.
the tuple is also always like it implies that you're always gonna want them combined, and this is not always the
But
case.
it is always the case. You always want either a text or a tuple of int and text. Because when you refresh something, it needs to at least be the text, and then you add the number and just carry on with the text.
Yeah, but he
Like
wanted to
we,
make an ADT because
well,
instead of a
the
tuple.
either is already the ADT, right?
Yeah.
You are in line, so yeah, you already have it. That's why we need the ADT. For the same reason you are calling the either.
No. But I forgot why we prefer the ADT instead of a tuple.
No, dude. What we need is the following. We need a type that is either text or a tuple with an int and a text.
Oh,
We
so
need the
you want
ADT in
this?
yes.
Yeah, that smells bad, man. But okay.
Well, because you are doing a line with a need there, that's why.
No. Even if I made my own, it would smells bad regardless.
But that's what you need, so
Okay. Now everything is broken.
unless oh dude.
Now
Let's do
everything is broken.
our language in F sharp. Not the. We can just have nulls there. We can have random numbers.
But you are doing that, sharp.
And
You are? I saw you.
I am.
Yeah, I saw it.
You saw it where, man?
Wow. When we were here?
Is that
When
what
I
you want,
was.
Nathan?
Yeah, something like it. Yeah. Regarding the equals,
Yeah. Now we need to think about the equal now.
the thing is, if they have the same int, they have the same text.
You
So
are kind of assuming that as far as I can tell.
no, dude. Like because we are renamed consistently, right? So and supposing that we don't have clashes, that well, we have to suppose that.
Mm-hmm.
Then every time you generate an int and you are like renaming for that, it will get the same text. Like you will not generate two different ints. How can I say? You can have two different ints with the same text, but not the same int with different
No,
texts.
that part I got. That part I got totally.
So doesn't the normal derived equals just worse for that?
I think so.
Wait.
Yeah, the normal one will say, oh, if both of them are names, then the text needs to be the same. And
Makes
and if
sense.
both of
So
them
we'll
are
have dinner and I'll be
okay,
back. And when I'm back, I'm gonna be doing you know what. Or maybe you don't, but
I
anyway, I'll
I
tell you.
don't. I
I
definitely don't.
don't.
But okay. Uh, uh,
Yeah, then the normal derivatives works.
okay. So deriving EQ.
Yeah.
This is gonna
So
break more stuff.
yeah, just the like if we would need the compare, then it would need a special one. But we don't need to compare to the map, right? Or do we?
What do you wanna do?
We are using maps, right?
You're using maps, yeah.
So for the maps, does the thing need to have a compare? Does it need to have to be a comparable for you to do the map with them, the type?
Never tried.
Yeah, so you need to check that because our map now, instead of the string to something, will be variable to something, right?
Yeah.
So yeah, maybe we need to derive the compare, and that would be a special one.
No, but this is the compare.
This is not the compare.
What are you
The
calling it?
compare is the one that is either doing like equal or less than or greater than.
Okay, so the equal is this one definitely. What the other one that you
Yeah.
want is
The
ord.
one that returns like it's what?
Ord.
Oh, okay. Yeah. So I'm pretty sure we cannot like just derive that.
Okay. Um, ord t variable.
No, no, but that's the thing. Do we need that to use the map? Otherwise, you don't need to implement it.
Okay, so let's double check that. Data map. Yeah,
It needs, right?
yeah, it needs to be ordable. Uh, okay, so what is the
Yeah. What is the returns? What does need to implement?
less than, less equal, or compare?
And what are those?
We need to make
Oh, nice. It returns ADT, right?
it returns. No, no, wait. The less
Compare
no, the compare returns an ordering, which is like greater or less.
ADT. Yeah. So in Okama, you need to return an int. So
Get
yeah,
freaking wrecked.
yeah. I would suppose that's because of performance of some stuff, but it is bad indeed. It's not like Rust and Haskell.
Uh, okay, but we need to do 4 cases, I guess. So
Uh,
label one.
oh shit, that's really bad in Haskell, Lamos. Yep. Yeah, that code would need a lot of that like OR pattern. But since we don't, we
This
have
is
to
an
do
error.
all. What?
Yeah, that doesn't make sense. Can
Of course it
compare.
does. You can compare the strings.
Yeah, you're gonna compare what? The size?
Like lexicographically. You can just use the art from the string.
I don't like that, but okay.
It's not that you don't like.
No, it is that I don't
Like
like.
you need.
No, no, I don't need. I can just throw an error. Uh,
You, you know that the map use these, right? So you cannot throw an error.
no, but the map will not have this, I guess. The map will have only the tuple one, no?
No.
No. Okay.
The map will have a variable. Could be either one, right?
Name ID. Oh, ID. Okay, so
Yeah, you do the same with the label, I guess.
you do the same with the label.
Yeah, the only weird case it's when both are name ID, I guess.
Okay, so the next one is label 1, ID. Actually, because you're not using that, I'm gonna just ignore it. That's actually something that I remembered yesterday when you asked about we were talking about when the things will be evaluated and stuff. Are we gonna have like garbage collection in our language?
Well, so far it's an interpreter, right? But of course we will, otherwise, well, you have to free and a lot, right?
ID
Well,
1.
or you can just like run forever without like deallocating. That's also a choice.
ID 2.
People have too much memory nowadays.
What is the weird? Is that
Yeah, that's weird because if they are equal, then they are equal. Otherwise, you compare the labels.
wait? Is it is always the label?
No, no. If the IDs
Oh,
are equal,
if ID 1 is equal to ID 2, then it is this.
no, 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 no. In that case, you just return the equality, right? The middle one in the ordering.
Oh wait,
Oh, shit, I forgot, I forgot. You are not using the compare, right?
no, I'm using the less
For
than.
some weird reason. Uh, so yeah, in this case, Oh shit, that's maybe you should use the compartment. I don't know what would be in this case. Like it is equal, but is it okay for you to say it's less or equal? Maybe, but I'm not sure.
I see, man. I see.
Dude, if you can use the compare, that would be a hell easier. Like,
Uh,
not easier, like, but we would be like more sure of stuff.
no, I'm gonna later I add it back. Okay, so
Yeah,
this is gonna
right?
be compare of them. Compare to me. Compare here. Okay,
Okay.
so if they are equal, then you return equal. Else,
You compare the labels. Yeah, I guess that sounds right.
okay. Now comes the big problem, which is that everything now is wrong. Good. Okay, so let's
Yeah,
start.
that's also called your problem. You are the one writing stuff.
uh, this is a type, what we just changed, so it needs to live in here. Type variable, yeah. So it needs to be type variable info now. Oh,
That
fuck.
info kills me every time, man.
We need to use a constructor
Yeah, yeah, the one that has the name, right?
name.
Only the name.
Okay, next one in the pipeline is the typer. So where are you using that? Type checking.
Wait, why don't you compile and see
Well,
the errors?
that's an option. Let's do
But
that.
you have the map, right? That you have to change the thing.
Oh yeah. Oh, that's where I need to go. Okay, so it's in here, I guess. No, here. No.
We have some message in Spatula.
Oh, here. Okay, so
Finished most of Omega. uh,
is this map that you're talking about?
yeah.
So instead of text to type, it would be a t variable to type.
Oh wait, shit. Shit, shit, shit,
you
shit, shit.
saw, you saw what I
Sorry.
saw.
Yeah, it's kind context. Wait, dude.
Why do you think I'm gonna compile this stuff?
Yeah, I suppose it's the kind context that needs to be the variable. Mm.
Okay, system random.
Yeah. I guess that's it. In the kind context, right? What was text now is variable.
See if this is enough. It is. Okay.
Dude, sometime in the future, Rust would be the main language that I will use for everything. Even though like it's not its use case, but I probably will. Just because of the tooling, man. Like I'm getting disgusted. This it's not disgusted, right? It's disgusted.
Disgusted.
Yeah. It's disgusting shit. The tooling of Haskell will come and the other shit, man. Like it's just like bad to deal with all of this.
I would
You
say
need
that I
you,
kind of the only point that I understand from the infrastructure that I don't like that I am with you guys is the fact that you need to every single time put the export and import list. Aside from
no,
that.
I'm not. No, I'm not talking about this. Not at all. This is a lot better than in Rust, like the module part. Not as good as Okama though. I'm talking about the tooling of the language. Like you always have to do too much for like simple stuff to write your code, man. Like
Well,
having a
that's
bunch
a
of
bad
problems.
example because I fixed the infrastructure just by adding this line, right?
I'm not telling the case of adding that library to it.
Oh,
Like
okay.
just look at everything that you had in the project and that you had to set up and you put templates and shit. In Rust is like that simple.
Wait, not in scope, but it's here. What? I'm confused. Oh, 142 t variable info. Did I write it? T variable. No, it is in here. Am I going crazy?
What do you want? Did
No, it is
you
saying here, not
did
in
you
scope.
export the constructors?
No, but it is in the same file.
Uh,
It is like t variable info here, and we are using it down here. What the heck? I mean,
you don't need to use that, right?
what?
You
Of
don't
course I
need
do.
to use
Yeah, this is
that
a t
here.
variable. Inside t variable, now we have this guy because we have different constructors and crap.
Oh, okay.
What the heck
Wait.
this thing is talking about? Not in scope data constructor.
No, try just to delete this because I think you don't need that, right? You construct the other type with name and name ID, and that you have the type of variable info.
Oh no, you're correct. I am the dumb one.
If you're saying. Yeah. Nice.
Okay, next. Duplicate. So probably I forgot to remove
Oh,
this.
you're right.
You're gonna use Rust for, I don't know, web stuff.
Well, people do use it for some reason, but I guess they shouldn't for most cases at least. Yeah, but there is some like surprising use cases. Like for CLI stuff, it seems that they have like really good libraries in Rust, right? So even though you would not need like all the characteristics from Rust, they have a like really nice ecosystem for CLIs and stuff.
36, 40, 40. Oh, okay. The type substitution needs to be aware of this thing now. So if you have a name, you do. I guess you do what we are doing. What if you have a name with the name ID?
No, do. That's a thing, and ideally we should do that in a better way. But the variable needs to be abstract. You will never pattern match on it.
The variable needs to be abstract.
Yeah, like you just get the variable, and well, you have an equal for them, and you use that. You will never see if it is a name or a name
Yeah,
ID.
but then the type substitution needs to receive type variables, not text.
Yeah.
Oh crap. I hate it, but okay.
Like, what would you do if it's the other case, eh? Wait, it's not the variable, right?
It is the variable info. Uh,
Also in abstraction substitution.
okay, so we have something. We know what it is, and
Dude, like if you don't know yet, you have to learn how to do the abstract type stuff in Haskell, dude.
what do you mean, man?
Like it would help your life a lot.
You abstract type, you mean using the A here?
Well, that's abstract type, indeed, but that's not what I mean.
Okay, so I don't know what you're talking about.
It's like you have a module called variable, and it has like the type t and some functions that operate on the t, but you don't know what t is.
Yeah, so it is the A here. I don't know what A is. Can be whatever.
Again, both are abstract, yes, but they are not the same kind of stuff.
Yeah, so I don't know
Maybe
what you're talking about.
let me look here on Google.
Da, 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 da.
Existential types Haskell. It's just like hide information, right?
Pa 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 pa. Oh wait, this thing is not a text also anymore, right?
Yeah, it is not.
This is also a t variable. And this thing is also not. It is also a t variable info.
Oh, okay, I example. Do you remember the complex numbers that we did in Okama? Hello?
I'm back. I'm back.
Oh. Do you remember the complex numbers that we did in Okama?
Yeah.
So internally, it was a record with two integers, right?
Yeah.
But externally, you didn't know, and you could not like construct one or access the integers inside.
Yeah.
Okay, I'm
That's
back.
what I mean.
So what has happened?
I don't know how we will use that in this context, Nathan, but I think I got what you mean.
The context is the variable should be abstract.
The context that the variable should be abstract.
Yeah, to guarantee invariance, because then you would not be able to create a variable that is name ID with some random integer that you did. The only way to generate one would be through refresh. You see?
Oh, you're still on the random shit.
But he did a bunch of like substitution on
I
the
know.
code
I know
already.
how to do that, but it's too much work. It's too much work for
No,
now.
I'm not saying you should do, but like it's useful for a lot of other stuff.
No, we are not doing the random stuff. We are changing the. We are now that we have this new extra stuff. We are going through the errors of the compiler and like that Haskell is throwing at us, and then changing it to the correct stuff. So 31.
Just out
This.
of curiosity, can you give me like some word or link on how you do that in Haskell?
Uh,
The information hiding?
yeah, you just don't export that. You make a module, you put all of that in a module, you don't export it.
Oh,
Oh, you said you don't export like the
oh,
constructors,
you
right?
Yeah.
mean like you mean like adding private in your object, right?
Yeah, yeah, like that.
You mean that in private?
Like private in your, what's it called? Like properties?
Methods,
No, no.
methods,
Yeah,
properties,
methods also,
depends.
but yeah.
Abstraction info is not a text anymore. This is also this thing, right?
Abstract info. Yes.
Uh,
Oh.
this is reverberating harder than
Wait,
I
wait,
thought.
wait, wait, wait.
This needs to be, man,
Ah,
because we are comparing it here.
Oh, the
yeah.
parser will be
Abstract info.
amazing now.
Yeah, yeah.
Wow, all of this because we didn't want the gambiarra down there. Holy crap.
Well, we could have abstract what the labels were like from the
Man,
beginning.
everything. Oh my god. Oh, this is gonna take so much longer to fix.
No, no, but the show is so easy to implement for the variable, man. It's just get
Oh
the
my
string
fucking god, this
part.
is already 2 hours and 40 minutes. I'm gonna finish the recording now.
Oh, it's way, way